It's kind of quick.
Yeah, not that much left in the semester.
5 weeks.
Oh, yeah.
It's not going to go very far.
Less than that now?
You're not doing fine, right?
It would be. I think it's 5 weeks from Wednesday. So I think that's right. Yeah, 4 weeks from next Wednesday.
That is terrifying. That's terrifying. That's what they were saying. Now, man, you get. Yeah.
Thank you.
See, he's getting.
Could have been better.
No, but he's 5. He's a lot. I just don't know. It's not bad. It's just a lot. I haven't so.
Yeah, it's fine.
In the class.
I moved everything up this summer.
I'm doing it right now.
Be done by Thanksgiving. Long break.
I'll see. That might be scheduled to do a project.
There's a. Yeah, I'll be around.
Pretty high probability.
It's different.
I don't know how these guys did it last year or the years prior to this. So we're really trying.
Yeah. Yeah, you get a lot done by the break in the beginning of next semester. Next semester, it's usually not too bad. So I got pretty good classes you're taking.
I'm following the setup that it is.
Well, you'll have the 454 here. Homework, not much. Not much else. Yeah. Yeah, I don't know how time.
All I did is probably we'll see. All I did on Tuesday.
I wanted to talk a little bit about the next project because the inputs and outputs here are not really the inputs and outputs on your microcontroller board, right? They have to be mapped to. So the inputs here in the project are, you know, it's supposed to be set up when you press a switch. That causes, you know, a 1 to be sent, but if it's held in, it no longer gives 1s, right? Or if it's released, it no longer gives 1s. So you only get a 1 when the button is first pressed. Our push buttons don't act like that. So you have to map, you have to simulate that behavior with the push buttons on our board. So, I mean, so the inputs here of 0, 0, 0, 1, 1, 0, that's not what you're going to get when you read those switches. Actually, when we read our switches, when they're depressed, you get a 0, right? But that has to be mapped to, you know, the inputs that are in the problem description. And just like the red, green, blue, you know, the states here, when it's in the red state, the red LED comes on. You know what the output port has to be for that, right? So this is kind of just a generic state diagram with 2 inputs and 3 outputs. And then you have to map these values to the actual values you need on your development board. Okay. Are there questions about that? The other thing in the code that was provided in the textbook, you know, he uses an array. He uses pointers to the next element. You don't have to do that with an array. Actually, I probably wouldn't with an array. I would just have the next step be the corresponding index in the array. Okay, so he initializes the array with pointers. You could just as easily, I say that, you know, he has 4 struct state. I think it's int out, int wait, and these may be uint types. I don't remember. It doesn't matter. And then he has this array, struct state, of 4 elements. And then, the output is, I don't know, 10. The weight is 30. And then for initialization, he has here for the next, what I think in the first state, he has it come back to the first state in the 0, 0. So, but he's using pointers. The pointer to that next state here would actually be states 0, and then we want the ampersand of that. Would be the 0th element of this array, which is this first element, is a pointer to it, and then the next is, states 1, okay, which would be a pointer to the next element. So if the input is 0, 0, we set our pointer so it points to the same row. If it's 0, 1, the pointer is set so it's actually pointing to the next row in this array. He actually has defines for each of these. Like I think this one's go in and this one's wait in or something like that. But if you look at the definitions, go in is nothing more than ampersand states 0. So it's a pointer that points to this element of the 0th element, the first element of this array. There's nothing, this is just an array of structs. There's 4 elements in the array. And ampersand states 0 would point to the first element. So in his while loop, he's got a pointer, struct state pointer that's initialized. He starts it out with a pointer to the first state, states 0. And then what he does, he grabs the output. So the pointer is initially pointing to this first row. Here's our desired output. So this is some, I think he calls it lights, but it's actually just some port out. And we really can just set it to pointer star. And then we want to pull out that value that corresponds to out. Now he masks that off so it doesn't affect other bits, but that's essentially all he's doing is setting lights again as it defined to a particular port. I think it's P4 or P5, I don't remember. But he's essentially doing that. And then he's waiting, what's that called? Sys-tick, wait 10 milliseconds or something. And again, it would be pointer, the second element, which is wait. So we're going to wait here so many seconds, and then we're going to get our next input. I forget how he does this. Reading a port, I think I'm just gonna say we're calling a function that's gonna read the 2 switches and return a single value for us. But then this now defines our next state. So our next state would then be equal to our current state, and then we've got to pull out the pointer here to the next state. And input can be one of 4 values, 0, 1, 2, or 3. So if input is 0, it's setting pointer back to the states 0, the pointer to state 0. If it's 1, it's setting it to the pointer to state 1, which means our next state will be the next line. And we'll next time through the loop, we'll set the output to whatever the output is here. We'll wait this amount. We'll get the next input, which will then take us to the next state. Questions about this? I guess this is actually not an array of ints, is it? It's an array of pointers to I think is that what it has in the book? Something like that. That's what it should be, I think, is this is actually an array of pointers to the next states, which are structs. If you're going to store them in an array, you'd have to use something like this if they were stored in a linked list. If you're storing them in an array, I really don't see the reason to use pointers. I think you could just very easily use indexes instead. So now we've got the array here, and equivalently, we would do 0 to come back to the same state, 1 to go to the next one, 3 to go to the last one, and then 2. Now that changes things over here. You could use a pointer, but instead I would use like a current index first, starting in state 0. Now all this is different. Instead it would be states current index. That's going to pull out the zeros, well, whatever we're currently in state 0, and then now dot out to get the value 10. And then similarly, this would be states current index weight. And this would be, we're going to update the index. Current index would be states current index. Call it next, and then whatever the input value is. So it just updates the index, so it points to the next array. I don't care what you do. You can use the pointers like he has in the book. I'm not sure that this is any cleaner, but if you're working with an array, you've got a much easier way to access the elements of the array is actually by the array index instead of by using pointers, but it doesn't matter. You can use either. I lost everyone. You're going to have to play around with this and try some code. The body of the code is I mean, this is it. This is the program. Now you're going to have to write this input function to do that mapping for you. And this is not going to work. Well, it could work. I mean, instead of the output values that I have there, you actually have the output values to set the red, green, and blue LEDs. So that the output here to turn off the LEDs and the out and the to turn off the LEDs is 0, right? To turn on just the red, it's factory which port pin it is. But you can, and then for us, is it port 2 that has the LEDs and port 1 the switches? So it'd be P2 out. And you can make it a little nicer by not affecting the other bits in the output port, but you don't have to. We're the only ones actually using the microcontroller at this point. But in larger programs, that would be considered better programming. So any questions? Any questions about in the homework problems? I don't have, it's the first time I've taught this course, I don't have previous exams for you to use. So the way I plan to make the exam, I'm going to look over the homework that I've assigned, look over the projects you've done, and come up with similar questions. Not questions that are exactly the same, but similar questions. Okay, so like, how do you? We had some homework on, right? Some array manipulation, right? Computing the dot product of two arrays, finding the maximum value of an array. We had some homework working with structs, right? There was a complex data type, and you had to write some functions on computing the absolute value, computing the sum of two complex numbers. You know, we've done some stuff actually since the last exam. I mean, it's some port manipulation stuff. You know, how do you turn on and off a bit? Probably a question like that without affecting the other bits. You know, you had a project where you know, you had to do a simple transistor driver for an LED. You had to calculate the resistances. You had to hook up an external pull-up resistor for an external switch in one of the projects. Even though you haven't completed this project yet, you know, there will be some state diagram stuff. Maybe come up with a state diagram from the state table, like the first part of this project. So any of the homework questions you want me to go over? Or question, would you like to try to come up with some? We talk about the switch mapping so it satisfies the definition here in the table if you want. Should give that some thought. Okay, it's not. You will need like a state variable in your input function to keep track of what the, whatever you want to call it, the previous state was. You know, that it was either pressed or not pressed. Then when you go into the input function, you want to see if it wasn't previously pressed and is now pressed. That's when you want to return a 1. And then you update the state variable. That's the only time you, and then for any other condition, you want to make sure that you don't return a 1. And you can do this actually so that, and I don't really care, so that this thing returns immediately, returns 0, 0, so it will always stay in the state. The other way to do this is you could stay in the input function until one switch or the other is pressed. I don't really care how it's implemented, right? In the state diagram, it says if input is 0, you really stay in the same state. That's essentially doing nothing, right? So you could write this so you don't actually return until one switch or the other is pressed. That's the only time you actually need the transition. So however you want to do that. So any questions about the homework related to arrays or the structs with the complex, or what have we covered since the last exam? So, you know, we looked at the clocks and timers. Make sure you know how to use those weight functions that are present. Pointers, arrays, strings, structures, finite state machines. Oh, what we just looked at with two-dimensional arrays are actually setting up the graphics memory. So we looked at some simple functions there. There were a couple of homework problems on manipulating that screen memory and just set it to all ones or something like that. So. Yes.
Will the exam be open book?
It'll be open book. So you'll have the book to refer to. I'll try to remember to, if I use the state diagram in there about the stoplight example or something, I'll try to remember to put the page number in on the exams. So you guys know it all then. Okay, we can just go. Ready? All right, no questions? Last chance, like I said, when we leave, you're not allowed to ask any questions for the rest of the day, so.
So we can't use our notes.
No notes, yeah, and then just the book. All right. Have a good weekend. If we don't have a good weekend, a lot of you will see you in a couple hours.
Good.